Hey guys, here's the video for the 9.3 homework. Probably won't do every question, but I'll try and do similar ones. So for the first set of problems, 1 through 4, find the area of the triangle using sine functions. So what we're going to be doing is there's a formula that we were able to use using the law of sines in order to find the area of a triangle. Now I'm not going to go over how the formula is being derived, but essentially you can only use it in the cases of a side angle side, which is funny because that is not one of the cases that you can use the law of sines in, but it is the only case that you can use it with to find the area of a triangle. But in any case, so the area of this triangle right here can be, we'll set up by using 1/2 of the two sides, so 15 times by 13, the product of all these, times by sine of 57. And so if you put this into your calculator, you should get the answer. So if it were me, you can do 1/2, or you can do 0.5, and then 15 parentheses. Let's see, it was 15 and 13. So 15 parentheses 13, and then it was sine of 57. I do have to make sure, yep, I'm in degrees. And then, so let me just make sure, 0.5, 15, 13, sine of 57. And then I got 81.8. So area here is going to be equal to 81.8. And you can do the exact same thing for the other ones. It doesn't really matter. As long as you have the side angle side, as long as you have those set up as side angle side, then you can use this formula. And again, it's just 1/2 of the product of the two sides times by sine of the angle that's in between them. So if I can do one more just to show you guys, for this one, I would say that the area is equal to 1/2. I would do 24 times by 28 times by sine of 83. So type that into your calculator, get an answer. You'll do the same thing for 3 and 4. For these next 4 right here, it says state the case of angle, angle, side, angle, or side, side, angle. Then decide if the measurements given can make one or no triangle. So let's go ahead and try this one. So if I just draw the triangle, so I'm just going to draw a triangle. It's not going to be to scale, and the angles aren't going to be as they are. But so here, I'll mark this as angle A, so that would be 49 degrees. And remember that opposite to angle A is side A, so meaning that this would be 24. And again, it doesn't really matter as long as you're consistent. Angle is opposite to side. So if I call this angle B right here, that would mean that this is side B, which is 22. So you can see here we have a case. Well, we don't have two angles known, so it can't be this one and it can't be that one. So the only one that we have is the side angle. So we have two sides and an angle that is not in between. So that's what this means right here. So yep. Now, can you, with the measurements that they have provided, can they make one or no triangle? And in the case of side angle, it all depends on the height of the triangle. So if you were to find the height of this triangle right here, well, we just made a right triangle right here. So I'm going to use sine to find the height. So sine of 49 degrees is equal to h over 22. So remember that sine is equal to opposite over adjacent. We're using the right triangle, not this triangle right here. So this is the opposite. This is, or sorry, opposite and hypotenuse. And then that would mean that the height would be equal to 22 times by sine of 49. So if you've got a calculator in hand, go ahead and type in 22 sine of 49. Let's see, I'm in the wrong mode. So, and I've got, the height is 16.6. So this height is 16.6 right here. This side opposite to A is 24. So imagine that we have this side right here. The length is 24. Imagine that this angle is rotating on a hinge. I don't know what the angle is here. So this would be angle C, right? I don't have angle C. It's not known to me. I also don't know what side C is. And so both of these are unknown. I do know that angle B is unknown and side B is known. So the only thing that's set in stone is this angle that we have. Is this angle. This angle has to stay the same, and this length has to stay the same, and this length has to stay the same. But this angle, and this side are unknown. So if this is 24 and h is 16.6, that means that this side right here is longer than the height. Well, this side is also longer than this side over here. So imagine we have this length of 24, which is on let's say that it's operating on a hinge. Well, since side C, this side is unknown, how many triangles can I make with this side being 24? So if I imagine that I'm rotating this on a hinge, that the only triangle I can make is whenever it meets up with this side right here. So if this side is longer than both of these, that can only happen once. This side can only intersect with this side at one given time. Now, had this side right here been, let's say, 15. So let's say that B was 15 let's say A was 15 instead of 22. 15 is less than both of these sides right here. So 15 would end up being short, and it couldn't even reach the other side right here, making no triangle at all. And let's say that A had been something like 20. So 20 is less than this side, but greater than that side. So that would mean that if it's less than this side, and imagine again that you're operating on a hinge, well, it's greater than this side right here. That means a side length of 20 could meet here and here. So it could meet on both sides of the height, making two different triangles. So it all depends on this height right here and the length of this right here. All these lengths are going to play a role into how many triangles you can make. But in this case, we can only make one triangle. And that is because this side right here is longer than both the height and the other side provided. All right, going over here. Again, let's make a triangle. It's not going to be to scale by any means. So I'll just do the same. So this right here is going to be 50 degrees. For A, we'll call this B. This is 30 degrees. And side B, which would then be opposite over here, would be 8. So what case do I have? I have two angles, and I have a side that is not in between. So that's going to be an angle side. If we had side C right here, then we would have angle, side, angle. But yeah, this would be angle, side. And angle sides will only make one triangle. Because this angle is fixed, and that would mean that this angle would have to be fixed as well, meaning that you could only make one triangle. Going on to 7, so make a triangle. We'll call this angle A. We'll call this angle B, which would mean that this is 95 degrees. We'll call this angle C, which means that this is 46 degrees. And we have angle side A, and side A would be right here since that's opposite. So in this case, we have an angle, a side, and an angle. So angle, side, angle. And same reason, this can only make one triangle. So same reason as number 6. Here we have one angle, and it is obtuse. So that's one thing that I'm going to keep in mind, that when I draw this angle, I'm going to make an obtuse angle. And we'll call the obtuse angle, we'll call 120 degrees. So this is C. We know the side opposite to it is 11. We'll call this angle B, and that means this side is 12. And you can already see here that no triangle can be made. So according to our setup, the side opposite to the obtuse angle is only 11. But this side right here is 12, which doesn't make sense because the side opposite to the obtuse angle would have to be the longest. So because this side right here is shorter than this side, and we have this angle, meaning that I can't make a triangle with the given measurement, so no triangle can be made. All right, for 9, this is actually using the law of sines. I'll go through a couple examples here, but not all of them. So in this case, I have an angle, side, angle. So this is a case of angle, side, angle. And well, the first thing, that whenever you have two angles, it's always easy to solve for the third angle. You're just going to do 180 minus 85 and minus 47. So I know that this angle is 48. And now I'm going to solve for these two sides right here. Kind of just rewind a little bit. Remember that the purpose of the law of sines is to solve a triangle in the case of angle, side, angle, 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 side, or side, side, angle. Now I'm going to find one of these sides. So I'm going to find B and C. So B and C. I'm just going to, I guess, choose B right here. And remember that the law of sines is set up accordingly, where you have A over sine of A equal to B over sine of B equal to C over sine of C. I like to use it in this format if I'm solving for a side. So the lower cases are the sides, and that's what I'm solving for. And it's best if it's easier to solve and uses less operations if you have the unknown variable on the numerator. And so I'm gonna pick to solve for B. So B over sine of 85 is going to be equal to, now since I don't know side C, I want to avoid using this part right here, so I'll use A because I know both the angle and the side. So this will be 19 over sine of 48, and the only thing I need to do here is to multiply by sine of 85 to the numerator over there. So B will be equal to 19 times by sine of 85 over sine of 48. So 19 sine of 85 divided by sine of 48. And we get that B is equal to 25 point, round to the nearest tenth, so 0.5. And now let's solve for C. So C over sine of 47 is equal to, and I'm just going to stick to using this right here, 19 over sine of 48. And doing the same thing, I'm going to multiply by sine of 47. So 19 times by sine of 47 over sine of 48. So 19 sine of 47 divided by sine of 48, and I've got that C is equal to 18.7. So got every part that I needed right there. Okay, so this was a case of angle, side, angle. This would be a case of side, side, angle. So let's go ahead and do this one right here. So the only part that I have both of are C. And I can't use the rule of sum of 180 because I don't have two angles. I only have this one right here. So something to keep in mind is that I don't have any part of A. So I don't think I want to start with using that. I think I want to solve for angle B first, since I have both C, so I have to use this one right here. And I have side B, but I'm missing angle B. Now, because I'm going to solve for an angle and not a side, I'm going to use the alternative setup where I write the angles on top and the sides on the bottom. And so again, I like to keep the unknowns in the numerator rather than the denominator. It uses less operations. So again, I don't know any parts of A, so I'm not going to use this in my equation. I know both parts of C, and I know B right here. So I'm going to say sine of B, which is the unknown, over 16 equal to sine of 104 over 25. And then I'm going to start by multiplying by 16 there. So sine of b is going to be equal to 16 times by sine of 104 over 25. And then I'm going to use sine inverse on both sides. So sine inverse of, or I'll say this right here, b will be equal to sine inverse. Because I'm using sine inverse to get rid of sine over here to get b by itself, I have to use sine inverse of all of this right here. So this is going to be equal to sine inverse of 16 sine of 104 over 25. So 16 sine of 104 divided by 25. Whoops, I did the wrong thing. Sine inverse of 16 sine of 104 divided by 25. And I've got 38. So angle B is equal to 38.4. And now that I know that this right here is 38.4, I can solve for this angle. So 180, subtract 104, subtract 38.4, and I've got 37.6. Now all that's left to find is side A, and make sure that you do not use the Pythagorean theorem because this is not a right triangle. So, but I am just going to use the law of sines where I'm solving for A. So A over sine of 37.6 is equal to, I'm going to go with C because those were the original parts that were given. So 25 over sine of 104, and then I'm just going to multiply that over here. So A will be equal to 25 sine of 37.6 over sine of 104. So 25 sine of 37.6 divided by sine of 104. And I get that side A is equal to 15.7. There you go. All right, and then let's see if there's any other cases really. So we had a side angle. This one was a side angle. And this one right here is an angle side. However, it's really not going to be different from an angle side angle because we have two angles. So I would start by solving for this angle. And then in that case, you have all of parts of C, but you need to solve for side A and side B, which you do the same exact way here. But I think I've covered every possible scenario, maybe except for 14. So for 14, I would just reference this question right here and save you a lot of work. Okay. All right. That should be everything that you need for the 9.3.